All right, so we're going to use a patty paper, a pencil, I think that works best, and a circle that you should have found from the front of the room, smooth circle. And we're going to explore what a radian is. That's radian, it's R-A-D-I-A-N. What a radian, which is an angle measure, is. You're gonna create some. So the first thing you should do is very sharply score a thin width of part of your patty paper and rip it off. So I have one shown from a previous version of this. And the thinner the better, because you're gonna use that strip to wrap around your circle that you're making. And I said that right here. So it doesn't matter how rough one edge is, you just want the straight edge on the original edge of the patty paper side. So take whatever circle you have and a sharper pencil than I'm showing here and trace as accurately as you can a circle on your patty paper. I think one side's easier to draw on than the other, so explore that. Then in the light, look to the light, or on some white background, you're gonna very carefully fold over your circle so the circle parts match up on each other. Remember, the circle is just the circumference, that pencil mark around there. So you're gonna match up two of the halves, and that's creating a diameter. So very sharply crease that diameter, and you're gonna do this 2 times. They do not have to be perpendicular, so they don't have to be 90-degree angles to each other. So do that 2 times. Once you do that, make a center, so mark off the center. My little pencil mark is too huge. You want to be exactly at the center. Yeah, enough said. Once you do that, use any sort of, as accurately as you can, straight edge, and mark off what a radius is. So from the center of the circle to the actual circle. So that's 1 radius. And you'll see that next, take your strip of paper on the precise side, on the original edge, mark off as precisely as you can. You notice I keep saying that because the more accurate you are, the better your results, garbage in, garbage out. So mark off 1 radius on this strip of paper. And then of course you're gonna use 2 hands, but I only have 2 hands, and so one I needed for my janky camera work. You're going to, as carefully as you can, wrap around this edge on your physical circle there, because you want to trace out the length of 1 radius around your circle. So I'm starting at this original radius. Once I put the camera down, I wrapped it as neatly as I could, and finesse what you can. We all have different levels of manual dexterity, but the more you practice, give yourself grace, the better it is. So be as accurately as you can and mark off 1 length of a radius on your circle. And then, as you see, I'm giving myself grace. Oh, look, I can do that. See, I'm not very accurate there. You want to be more accurate than I am, and trace out another radius. So there's your second radius. Rude. Okay, there we go. And voila, you've made 1 radian opening. So a radian is the measure of an angle. You've made 1 radian width opening on your circle. So the definition of a radian is, or how many radians you have, is how long of an arc you travel around the circle divided by the length of the radius. So since the arc we've traveled on our circle is exactly the length of a radius divided by the length of a radius, this opening is 1 radian. So this is the big important part here, as a reminder, that a powerful thing happened here. So you know how we measure angles in degrees, usually, from what we do. Radian is, even though we say it's 1 radian, a radian is unitless, because by definition, you're taking the length of the arc divided by the length of the radius, you're canceling out the units, and it's the resulting opening, that angle size, is unitless. And you're like, okay, that's weird, and why is that important? Very important for calculus, which I hope I will keep talking about, and math, because when you're using actual angle values in math, the units travel along, even though we might not play with them on paper. But you don't want to say, oh, how long did you travel around in the circle? You don't want to go, oh, I traveled degree feet. You don't. You just want to say I traveled this many feet, etc. So we'll talk about that later. And now we want to see, well, how many radians are there around a full circle? So you're going to keep doing this on this second radius that you have created. Make a sharp crease over that. So just fold over it, use the light or lighter surface, and be careful, make sure your circle edges or your actual circle match up. So you're gonna fold it over, and wherever it ends up, so this one I've already folded over, wherever it ends up, and do you see this part right here? You're gonna mark that off, and that's 2 radians. Now I have 2 radian openings. And keep this going, so keep going around. So now I'm on the path to have 3 radians, etc. Keep it going, see how many full radians around a circle. And spoiler alert, you can think about what's the circumference of a circle. And the formula for circumference of a circle is, what is it, people? It's 2 pi r. So that just means there are 2 pi radiuses around a circle. And since we're ticking off how many radiuses around a circle, well, 2 pi is 2 times roughly 3.14159, blah, blah, blah. So it's roughly 6 plus some change. And you'll notice you have 6 plus, see there's this little piece over here on another one I've made. And here's another one I've made. If you can count it out, there's a little piece left over that's less than 1 radian. So there's 6 plus some change radians around a circle, which is 2 pi r. So the last thing you're going to do, find somebody in class, get up, stretch your legs maybe, or turn around, meet somebody, and compare circles. Hold them up to the light, let each person do that. And depending on your accuracy, we're all humans, we'll make mistakes, but your angle, like hold up the centers of each circle, your radian openings should be exactly the same if everybody was perfectly accurate. But it doesn't matter the size of the circle, it doesn't matter the radius, but 1 radian will always be the same open angle measure. So that we will now probably take notes, talking to future me, and I made this video for people who want to watch it again or think about it, or maybe might have been absent on this day.